You sit down, type a question, and within milliseconds, a cursor blinks back with a perfectly structured, nuanced answer. It feels exactly like you're talking to a highly educated, articulate human being. But the process generating these words is mechanical. Behind the flawless grammar, the system is performing a calculation, following a logic that has more in common with a calculator than a conscious mind. Computer scientists often refer to this as a stochastic parrot. Just as a parrot might repeat the sounds of a conversation it heard through a window without knowing what the words mean, these models replicate the patterns of human language without an internal life of their own. Take the prompt, "I am hungry, I want." The model maps the next word using mathematical probability. Paths to food, like biryani, grow thick as it assigns high percentages based on past conversations, while unrelated words like bicycle are zeroed out and ignored. Because the system only sees the probability of the next character, it lacks any actual comprehension of the subject. It is a blind statistical guessing game. But if the system is just a sophisticated version of autocomplete, why can it write original poetry in the style of Shakespeare, or break down the complex nutritional profile of a rare fruit? A model trained on a small, localized set of conversations would be highly limited. It could only repeat the handful of phrases it had been exposed to in a specific household or office. The leap from simple mimicry to apparent genius occurs when you apply this predictive logic to millions of books, academic journals, and digitized libraries. In the realm of artificial intelligence, a sufficient increase in the volume of training data eventually produces a result that looks less like a math problem and more like a creative mind. To reach this level, developers moved past basic language models and built large language models, like GPT-4 or Google's Palm 2. Building an LLM requires an ingestion of data on a massive scale. Millions of books, the entirety of Wikipedia, and the chaotic open internet condense into a single core. Inside are trillions of connections, called parameters, creating a dense map. This trillion-parameter web allows the model to traverse incredibly diverse concepts in an instant. It can combine separate ideas, like explaining quantum physics in the style of a pirate, by tracing the statistical links between those two distant data clusters. This vast scale creates the appearance of deep understanding across almost any subject. But by swallowing the entire internet, they inherited a catastrophic blind spot. The open internet is a digital record of our most toxic, biased, and abusive impulses. It is a dataset filled with hate speech and vitriol. An LLM lacks a conscience. It treats a racist forum post with the same mathematical weight as a historical fact. It absorbs toxicity just as eagerly as it absorbs science. These models act as an unfiltered mirror of humanity. Because they are designed to replicate their training data perfectly, an unconstrained LLM is highly likely to output offensive, abusive garbage. The machine simply executes its core mathematical directive: predict the most likely next word based on what it read online, regardless of whether that word is helpful or hateful. A technology that mirrors our worst impulses is unusable in the real world. To make it safe, humans had to intervene and force the machine to behave. To fix this, developers use a process called reinforcement learning from human feedback, or RLHF. This requires immense human labor. Thousands of workers, including data labelers in Kenya, manually review outputs, acting as an external moral filter. When the AI produces a toxic response, workers flag it with a red signal penalty. Helpful responses receive a green signal reward. Over millions of repetitions, toxic pathways wither and disappear, while polite, helpful pathways are reinforced. RLHF is the leash that civilizes the technology, manually overriding the machine's instinct to copy the worst parts of its training data. This process results in the helpful, empathetic-sounding chatbot we interact with today. But even with this layer of safety, the model still possesses zero subjective experience or emotion. It does not feel the kindness it expresses. This helpful persona was forged by millions of human feedback signals, a layer of politeness draped over a web of statistical math. As these tools become a part of our daily lives, we must remember that the mind we think we see is an illusion. Beneath the mask lies a meticulously trained